we are given a regular triangle. The point P is inside with PB equal twice of PA, and this angle is 120 degrees. If the triangle ABC has area of S, what is the APC's area? All right, as in any geometry problem, the key is to find the proper auxiliary line to solve the problem. Now here, however, we're going to use a common fact in analyzing the problem, which is if you have a triangle and you have a midpoint on one side, we claim that the two triangles have the same area. Why? Because area of triangle is half of base times height. In this case, both height is the same, right? So that's why if the base has the same length, because M is the midpoint, the area of the two triangles are the same. All right, so that's something we're going to use for this problem. Let's go back to the original problem. The key here, as I said, is to figure out the auxiliary line. In this case, we're going to make the connection, the midpoint here, since BP is twice of PA. So we claim that because of the midpoint, BM is going to equal AP, right? So this segment here, they all equal to each other. Now, another thing is, let's look at the angle as marked here, because ABC is a regular triangle, which means angle 1 and 2 here is going to be add up to 60 degrees. And since this is 120 degrees in this triangle here, 1 and 3, the remaining two angles, is going to be 180 minus 120. That's 60 degrees also. Now, which means angle 2 is congruent to angle 3. So let's look at this triangle here as I marked in the next diagram here. Now we have highlighted two triangles. They are congruent. Why? We just argued that the side, the angle, and the side are equal to each other. So we know that these two triangles are congruent with each other. Now the consequence of that is this angle here is going to be congruent to 120 degrees, sorry. And the 9 segment, as we said, is equal to each other. And this MC would be twice of, because MC is congruent to BP, is twice of AP. Now, if we extend this 9AP here, extend it out, you notice that this is going to be 60 degrees because that's 120 degrees over there, just 60 degrees. So this is also 60 degrees, right? So the triangle is a regular triangle. In other words, these 9 segments all equal to each other here. Now earlier, we used the fact that if you have a midpoint of a triangle and you make the connection, we're going to have equal area. So the area we're interested in, let's call it X. So the area of the smaller triangle APC here, this triangle here, let's mark it here. This triangle here, yeah, A, P, C, this triangle here. All right, so that's the point here. So let's assume the area is X. We're looking for that. Now, since the midpoint P here is a midpoint here, right? We claim that the other triangle must have the same area we learned earlier. Okay. Now look at the other triangle. Let's highlight here. From this triangle here. Yeah. This is a midpoint. This is a midpoint here. So this area, the left hand side, is also X. All right. Let's remove this. So this is also X. Okay. Now, how about this bigger triangle? Again, we're going to use the same. M is a midpoint here, right? So this base here, BM, equal MP here. So we claim that this must be 2x, right, equal to each other. And since the highlighted triangle is congruent, so this must also be 2x here. So what do we get? So ABC's S is actually equal 2x plus 2x plus the 3 triangle with area of x. That's equal 7x. So x, which is the area of triangle APC, the quantity that we're looking for, is 1/7 of the big triangle. That's the answer. All right. So again, in here, what we learned is that if you find the right auxiliary line, is able to allow you to solve the problem, and also we use a common fact about the area of triangle if you have the midpoint M here. All right. So hope you like the video. Please subscribe to the channel. Thank you.